Okay guys, as you might have known, this is an episode of Keeping It Real, Rational Function Editions. In this channel, actually, on this channel, we'll be covering a bunch of concepts that apply to the MHF4UO course as it applies to rational functions. So first we're going to start off with the reciprocal of a linear function, the reciprocal of a quadratic function, and we're going to analyze rationals of the form ax plus b over cx plus d. Then we're going to go ahead and figure out how do we solve rational equations and inequalities. And last but never least is applications of rational functions, where you go ahead and solve those nitty-gritty word problems. So I hope you have fun on this channel and enjoy math and rationals because they're awesome. Okay, bye guys.
Okay, hi guys. In this section we're going to be looking at the rationals of the form ax plus b over cx plus d. So essentially, and the only difference between this section and the previous ones is that instead of seeing a horizontal asymptote of 0 when you do your tables and as you did in the previous sections, you're going to be seeing a non-zero horizontal asymptote. So instead of approaching 0, your y values are actually going to approach a non-zero number. So that's basically the only difference in this section that you're going to be seeing. Everything else, the tables, the end behaviors, everything that you do is going to be the same. So for instance, if we take a really simple function of 3x over x plus 2, so it's of this form, and we draw interval tables for it. So from the restriction, x cannot equal -2, we know that the vertical asymptote is going to be -2. So what we're going to do is we're going to have to prove the end behaviors around this vertical asymptote to sketch the graph legitimately. So basically we have to take values from the left of -2 and from the right of -2. So basically if we select values really close from the left of -2, we can see that -2.01, if we really zoom into the function, we can see that -2.01 is going to be somewhere over here, and then -2.001 is going to be even closer, and -2.0001 is going to be even closer. So we can see that these x values approach the asymptote. Now we want to know what happens when these values get closer and closer to the vertical asymptote. What happens to the y's? So as you can see, so basically what you have to do is you have to plug these values into your original function and see as to what it spits out as the y value. So we got 603, 6,003, and 60,003. So because they're really large numbers and they're increasing, we can say that as x approaches -2 from the left-hand side, you add a little negative on the top of it, y approaches positive infinity. So we can kind of sketch this behavior from the left-hand side. So we can see that y goes to positive infinity, so we draw an arrow going upwards. Now for it approaching the right-hand side, because that's another side of the graph. So value which is going to be to the right of it and very close to it is going to be -1/9. So that's going to be somewhere over here. -1.999 is going to be even closer. And then -1.999 is going to be even closer. So for these values we get -57, -597, and -5997. So because these values are negative and they're increasing in magnitude, we can see that y is going negative, is approaching negative infinity. So as x approaches -2 from the right-hand side, y approaches negative infinity. So we can sketch this part of the graph. now what we have to do is a different part of what is going to be unique to this section. And that is going to be the horizontal asymptote. So for positive infinity, we want to know, so we basically have positive infinity and negative infinity. We want to know what happens when x approaches to positive infinity. What is y going to do? That's the only way in which we can determine the horizontal asymptote. And what happens as x approaches negative infinity? What is y going to do? So basically we take really large values of x. So for positive infinity, we take 100, 1,000, and 10,000. So we are sure to increase these. So they get bigger and bigger. And if you plug these values into the original function, you can see that for 100 it's 2.941, and then 2.994, and then 2.994. So as you can see here, usually x is going to approach 0. But in this case, x approaches a non-zero number, which you can see is 3 because it gets closer and closer to it. So as x approaches positive infinity, we can conclude that y approaches 3. And it's going to be from below the horizontal asymptote, because these values are smaller than 3. So, and they're getting bigger and bigger to become 3. So you can see that they're approaching it from below the horizontal asymptote. So for this part of the function, you can state that as x approaches positive infinity, so from left to right, y approaches 3 from below. So you can sketch this part of the function. And then as x approaches negative infinity, you choose really large negative numbers, and you can see that they decrease to become 3. So you can see how it approaches it from above, because the y values are decreasing to reach that horizontal asymptote. So as x approaches negative infinity, y approaches 3 from above. So this part of the function is going to look somewhat like this. So there we have it. We have the sketch of the graph. We have the general idea of what the graph is going to look like. But again, to legitimize everything that we do, we have to pick points to prove that what we did was actually right and to confirm it more. So you have to choose a y point, an x point, which is in this part of the graph, or in this interval, and of that interval. So you kind of have to visualize from the graph as to where the point is going to be placed to determine the middle behaviors of the graph. So for this interval, I chose -6, and that came out to be, when I plugged that into the original function, it came out to be 4.5. So 4.5 is going to be somewhere over here. So it's from the scale of my graph, because I chose this as the horizontal asymptote, which is 3. So 4.5 is going to be somewhere over here. And basically that connects to make the graph look like this. And then for the y value, I chose 0. And then when I for this part of the interval, I chose 0 as the x value. And when 0 was plugged into this function, I got 0. So basically, one of the points is going to be somewhere over here for this interval. And this is what I mean by why you need a point to legitimize your work, because sometimes it also corrects the shape of your graph. So you can see that it looks somewhat like this. There you have it. That's the sketch of your graph for this. Hey guys, this is again section 3.3. Now we're going to do an application of functions of that form. So this is actually from the textbook, page 175, number 10, chapter problem. So after train derailment in North Ontario, the concentration C in grams per liter of a pollutant after T minutes in of 5,000 liter pond can be modeled by the function c of t equals 30t over 200,000 plus t when a pollutant concentration of 30 grams per liter flows into the pond at a rate of 25 liters per minute. So A is telling us to sketch a graph showing the concentration of the pollutant after t minutes. What happens is t becomes very large, and when a concentration level of 0.05 grams per liter in the pond is reached, the fish stock will be irreversibly damaged and one will disappear. So that's what C is asking us. So first, let's go with A and try to sketch the function that we have. Now for this, what we're going to do is that we're actually going to take the shortcut, and instead of making all the interval tables and things like that, we're going to use our knowledge of ratios. So basically, the function that we have is 30t over 200,000 plus t, where t cannot equal negative 200,000 because that would be 0 and we can't divide by 0. So basically, ratios tell us that for the vertical asymptote, obviously it's the same as what we always do, is its restriction. So the vertical asymptote is negative 200. For the horizontal asymptote, what we actually have to do is we have to take the ratio of the leading coefficient of the top variable and the leading coefficient of the bottom variable. So that's going to give us 30 divided by 1, because this is 1t. So the horizontal asymptote is actually going to be 30. The x-intercept, if you rearrange this and set it equal to 0, you can find that t is equal to 0. So the x-intercept is going to be 0, and then the y-intercept, all you have to do is sub in 0 for t. So if we substitute 0 for t, we can find that the y-intercept is also 0. From these key features, what we can do is we can graph it. So this is going to be t, and this is going to be c, the concentration. So we find that the x and the y-intercepts are 0, so they're going to be right here. And then the horizontal asymptote is at 30, so I chose this to be 30. And then, so this is the vertical asymptote. The horizontal, no, this is, oh, sorry. This is actually the horizontal asymptote. This is 30, and then the vertical asymptote is negative 200,000. So from these key features, what we can determine is that the graph looks somewhat like this. And again, if you want, for the end behaviors, you can draw tables just to verify the behaviors around the horizontal and vertical asymptotes. But now here is the application part of it. T can never be negative because we can't really have negative time. And so basically what we're going to do is we're going to ignore this part of the function, which is going to be in the negative part of the x values. So basically all we're looking at is this, which kind of looks like a root function. So essentially for B, what it's asking us is what happens as t becomes very large. So as t becomes very large, we know that it approaches a concentration of 30 grams per liter because that's the horizontal asymptote, and it can't touch it, it keeps on approaching it. For C, they ask us when a concentration of 0.05 grams per liter is reached, what will the time be? So basically, they're giving us the concentration or Y value, and they're wanting us to find the X value or the T time value in this case. So basically, we set 0.05 equal to 30 over 200,000 plus T, and we arrange for T, and we find that it's 333.9 minutes in this case. So again, you can write your therefore statement, and that is the time for this concentration.
Here we go, guys. We're keeping it real, rational function style. Today's warm-up is going to be, you have to create a function with the following. You're going to have two vertical asymptotes at x equals -1 and x equals +3. You're going to have a horizontal asymptote at y equals to -1. The x-intercepts are at x equals to -2 and x equals to 4. So let's set up the normal rational function equation, which is y equals ax plus b over cx plus d. Now let's interpret the values that we have. Okay, so two vertical asymptotes at x equals to -1 and x equals to +3. So we know that our vertical asymptotes are our values that we get from our denominator, so let's go ahead and plug those in. Since it gives us the value, we know it's going to be the opposite of the value that they give us, so it's going to be x plus 1. And same thing there, you want to write x minus 3 because it's the opposite of the value given. Here we also have x-intercepts at x equals to -2 and x equals to 4. What you want to do is write x plus 2 on the top and x minus 4 on the bottom. If you're wondering where I got these values from, you can just simply do x minus 2 equals to 0 for this one. X equals to +2. This one right here, you're going to do x plus 4 equals to 0 because the plus 4 is what we have, and the plus 4 is a x-intercept, which means its x value is 0. Let's see. Or sorry, the y value is 0. -4, so that's where these values came from. X plus 2 and x minus 4. Okay, so here's our equation, but we are missing a big part of it, horizontal asymptote. And the horizontal asymptote is at y equals to -1. Usually, if we had a horizontal asymptote, we would have to check, okay, since the horizontal asymptote is a is equivalent to the value of a over c, we would have to figure out, okay, so what is our a value or c value going to be? But since it's -1, we can simply assume that the negative is the value over here, the a value. And we know that -1 over 1 is -1, so this actually proves true, and there you have it. That's your equation for the values given, and that's a warm-up. Hi there, guys. This is Secret, and we're keeping it real. Rational Function Editions. This is 3.5. We're doing an application question. Now, I bought a case of the Shins concert t-shirts for $450, and I kept 2 of the t-shirts for myself and sold the rest for $560, and so I made a profit of $10 on each shirt. Now, how many t-shirts are there in total? Let's go ahead and define our variables. X is going to represent the number of t-shirts. X's buying price is going to be $450 over X, and X's selling price is $560 over X minus 2. Now, the 2 comes from the 2 t-shirts that I ended up keeping. We subtract 2 from the original because the original is X. X represents the original amount of t-shirts. $450 is the original selling price at what I bought it. Buying price of what I purchased it as, and $560 is the price where I bumped it up after I bought. So let's define this into our profit equation. We put 10 on one side because I made a profit of $10, and these are the 2 buying and selling prices, and that's a profit equation. Now let's go ahead and isolate for X. Now what we did here is find a common denominator. In this case, the common denominator for this fraction is x, and the common denominator for this fraction is x minus 2. So we go ahead and we multiply the values that make the denominator the same. In this case, you are going to have to distribute the negative 450 towards the entire binomial over here. So what you end up getting is 560x negative 450x plus 900 equals to 10 over x squared minus 2x, which is the common denominator. So what you want to do, since it is proportional and it's not proportional. In this case, it is equated and it's not an inequality. So what you want to do is go ahead, right ahead and cross multiply. This is going to be multiplied by 1 and the 10 is going to be multiplied by the denominator. So as you can see here, this is what we did. Go ahead and distribute the 10 into the denominator. What you end up getting is 10x squared minus 20x. And you want to bring over the 110x and the 900. So what you end up getting is negative 110x minus 900 is equal to 0. And well, let's look at our equation. 10x squared minus 130x minus 900 is when you go ahead and collect like terms here. And since you can tell the common factor between all these three values is 10, we go ahead and factor out a 10. We end up getting x squared minus 13x minus 90. Now, as you can tell, this is our familiar quadratic expression. What you want to do is take this and factor it. I'm going to go ahead and use the x method. You can use decomposition, whatever you're comfortable with. Here, x times x gives you x squared. And you're going to have 18 and 5. Since you want it to be negative 13, let's make the greater number negative. And what happens here is 5 times x is 5x, and negative 18 times x is negative 18x. If you add negative 18x and 5x, you end up getting 13x, which is our middle term. I'm sorry, negative 13x, which is our middle term. X times x is x squared, which is our first term. And negative 18 times 5 is negative 90, which is our last term. So if all these terms are the same as the terms here, we know that we've factored correctly. So let's look at our factors here. You've got x minus 18 and x plus 5. So let's see our values of x here. We have x is equal to 18. And if you want to know how I did that, you go and do x minus 18 equals 0. Bring the 18 over to that side. You've got 18. What I really mean by bringing it over is getting rid of it. So if you have negative 18 here, you're going to add 18 so it cancels out. But at the same time, you're going to add 18 here. Whatever you do to one side, you want to do to the other side. So you're going to get x equals to 18. Your other value is, x plus 5 equals to 0. Your other value is negative 5. Oops, I don't know if you can see this. Equals to negative 5. We know we can't have a negative measurement, so this value is now inadmissible. You are only going to look at your other value, which is 18. And yeah, that's your answer. Oops, that's ugly, 18. That's your answer. The question was asking how many t-shirts are there. Well, Sucrit bought 18 t-shirts.